In this lesson, we're going to take a look at how to quickly sketch a graph if you know what the parent function looks like and the equation that you're trying to graph has a translation, either vertical or horizontal shift. So first, let's take a look at a family of graphs, a set of graphs that all have the same general shape. If you take a look at y is equal to x squared, y is equal to x to the fourth, y is equal to x to the 12th, or in general, y is equal to x raised to an even number power. What all those graphs are going to look like is this. They are all going to be U-shaped graphs going upward, and they're all going to have a very important point, often called the vertex at 0, 0. So at the origin we have a point, and then the right and the left sides are going to give us a U-shaped. So they would look something kind of like this. The left and the right sides would be symmetrical. They would be the exact same size and shape, just flipped over the other direction with that important point at 0, 0. So if we have y is equal to x raised to an even power, and we have a horizontal or vertical translation, we can start with this graph and then take this vertex point, slide it left or right or up or down, and then come up with our new sketch of our graph very quickly. The only point that I have graphed 100% accurate in this graph is the vertex. The left branch and the right branch, depending on which one of these equations you have, is going to be different steepness. It's going to be a little bit steeper the higher the power. But if we're just quickly sketching a graph, we definitely can do that by finding this vertex point, and then knowing that these are all going to be U-shaped graphs, we could draw in that U-shaped graph. And if you're just doing a sketch, that would be enough. If you're doing a very accurate graph, you would need to plug in some x's, calculate some y's, and come up with more points. But for a sketch, this will be enough. So let me give you our example here. For this example, the directions are going to be to graph. I'm going to go through and do an example reminding you how this horizontal and vertical shift works. Generally, we're going to have equations that look like this. F of x is equal to, and we may have like x minus 3 in parentheses raised to the 8th power. Well, if I have to do a quick sketch of that graph, what I see is this looks just like y equals x to the 8th, except in parentheses here we have a subtract 3. So I know it's going to look just like the parent function. It's going to be a U-shaped graph with the vertex at 0, 0. But we need to know what that subtract 3 does. If you have any addition or subtraction in your problem, when you compare that to the parent function equation, that's going to give you a translation, either vertical shift or horizontal shift. And if the addition or subtraction is in parentheses, then that's horizontal shift. If it is subtraction, like it is here, it's going to slide your parent function graph over to the right. And if it's addition, it's going to slide it over to the left. So if I want to do a quick sketch of the graph, here's what I should notice. We have y equals something raised to the 8th power, which is an even number. Inside the parentheses, I have x minus 3. That will slide my graph over to the right 3 units. So if I wanted to come up with a very quick sketch, not very much of this is going to be accurate, but it will be accurate enough for us to make a sketch. I want to start with our vertex at 0, 0, because that's where the parent function has its vertex, and then do whatever translations we have. In this case, we're going over to the right 3 units. And then from there, we can draw in our general shape. Anything raised to an even power is going to be that U shape, so that would be a reasonable sketch for that graph. The only point that's accurate is the vertex. If we had to graph a very accurate graph, we could make an XY table and plug in some more values like 1 and 2 and 4 and 5, but for a sketch, that will work out just fine. For letter B, if we had f of x is equal to x to the 10th power minus 5. Here's what I see. we have x raised to an even power. I know what that parent function graph looks like, and we have some subtraction in this problem. And anytime you have addition or subtraction, what that does to our parent function is it slides it either up or down or left or right. This subtraction is not in parentheses, which means it is vertical shift. So this will slide our graph either up or down. And for vertical shifts, plus is up and minus is down. So this is going to take the parent function graph and slide that down 5 units and still be U-shaped just like the parent function. So a very quick sketch of this graph. Start at 0, 0, because that's where the parent function has its vertex. Recognize that we need to slide that graph down 5 units. That will give us our new vertex. And then from there, it will have the characteristics of x raised to an even power, which is a U-shaped graph. Again, the only thing that is accurate in this graph is this vertex point. In order for us to get a more accurate graph, we'd have to plug in more values. But if we're just sketching, that is a reasonable sketch. We have the important point in the right spot, and it has the same general shape as the parent function. Letter C, I'm going to do f of x is equal to x minus 1 raised to the 16th power plus 2. So again, as you take a look, I see that I have x being raised to an even power, so this will look like the family of graphs where you have x raised to an even power. I know what that graph looks like, and we do have some addition and subtraction here, some in parentheses and some outside of parentheses. This add 2 outside of the parentheses is vertical shift. Plus is up, minus is down, so this will slide our parent function graph up 2. Inside the parentheses, I have an x minus 1. If you have addition or subtraction in parentheses, that's horizontal shift. Plus is to the left. Subtraction is to the right, so this is going to slide our graph to the right 1. So, to sketch a very quick graph, I'm going to start at 0, 0 because that's where the parent function has its graph. I need to move it right 1 and up 2, so from our vertex here at 0, 0 at the origin, I'm going to go right 1 and up 2. That will give me the location of the vertex. If you wanted to label that, that would be the point 1, 2. And then from there, I do see it is x raised to an even power, so it will have the same general shape as all of the other graphs in that family. So it's going to be a U-shaped graph. And once again, the only point that's 100% accurate is the vertex. Everything else here is just a quick sketch showing what the shape of that graph would look like. So that's what it looks like if you have x raised to an even power. Let's talk about what these graphs would look like if we had x raised to an odd power. So if you had a graph of y equals x to the 3rd, or y equals x to the 5th, or y equals x to the 17th, if in general you have an equation y is equal to x, and it is raised to an odd power, in general, that's what we're going to say. It's really an odd power 3 or larger, but that's fine. If you have y equals x to an odd power, what that graph is going to look like is this. If you went through and graphed all of these and looked at a whole bunch of other graphs that were y equals x to an odd power, you would see all of those graphs go through 0, 0, just like the even functions do. And the right side does also look like the right side of the even family. It is the right side of a U-shaped graph, but instead of going upwards on the other side to complete this U shape, it goes downward but with the same sort of shape. So it looks like this. If you have y is equal to x to an odd power, that family of graphs would have their vertex at 0, 0, and then this would be the general shape. Again, depending on your exponent, these branches are going to be either steeper or not quite as steep, but we're just going to sketch the graph, so we're going to get 1 point accurate and then just draw in the general shape from there. So for this example, directions are still going to be graph, and I'm just going to do one of these. So if we had f of x was equal to, in parentheses, let's say we had x plus 3 raised to the 7th power minus, let's do 4. So here's what I see. We have y equals x raised to an odd power, and I know what those graphs look like. We do have some addition and subtraction. I need to look at those and determine what kind of shift is that going to give us? What is our translation going to look like? Outside parentheses, anything added or subtracted is going to be vertical shift. Plus is up and minus is down. So this graph is going to have its important point, which starts at 0, 0, slide down 4 units. And then in parentheses, anything added or subtracted is going to cause our graph to move right or left. Plus goes to the left, minus goes to the right. So this is going to be a shift of left 3 units. So if I want to draw a very quick sketch, I can do this. I'm going to start at 0, 0 because the parent function has a very important point there. I'm going to go left 3 and down 4 units. That would be about right here. So this point, that is the point -3, -4. If you were going to label it, you don't have to do that. We're just sketching a graph. But that point we want accurate. It was at 0, 0 for the parent function. We went left 3 and down 4. So that would give us the point -3, 4. And then after that, we're just going to draw in the general shape. So this right side is going to be kind of like the U-shaped graph, and then the other side, same thing, but going downward instead. So that would be a reasonable sketch for what that graph would look like.